This workshop is titled Bring Any Web2 Data on Chain. And basically what I'll be doing is I'll be demonstrating how we can use one of Flare's enshrined oracles to bring arbitrary Web2 data onto the Flare chain. So Flare is the blockchain for data. We have enshrined oracles that allow you to bring trustworthy data on chain. And so first of all, I'll motivate this demo by showing what data I'll be bringing on chain. I'll show you how we can modify this data, and then I'll just run the process in the background so you can see how the script works. Yeah, and I'll also explain how the protocol itself works and what's the workflow of that protocol. Before we get started, let me direct you to the Flare Developer Hub. So on the Flare Developer Hub, you can see written guides for the protocol that we'll be looking at today and other Flare protocols. And so if you go to FDC guides, Hardhat, and Web2 JSON, this is a more in-depth guide on what I'll be demonstrating today. And you can find additional resources here on the Flare Developer Hub. The second thing is the Flare Hardhat Starter. This is a GitHub repository with example code, which you can use as a baseline building block for your Flare applications. It has examples on how you can use different FDC attestation types and different Flare oracles and protocols in your applications. So yeah, what we'll be doing today is we'll be taking data from Star Wars API. And we won't be taking it from the first one because it has been broken for more than a month, but the second one works. So basically what this API allows us is it has an endpoint for, let me zoom this a bit. You cannot see it, and neither can I. But it has an endpoint which allows us to query data about Star Wars characters. So for example, if we query Star Wars API people -1, we would get Luke Skywalker and certain information about him. So yeah, let me just copy this, because this is the first of the 3 components of the request that we need. The second is, if we go to JQ Playground, this is a website that will allow us to play with JQ filters. And let me copy this in. Also, let me zoom in so we can see better. So basically, JQ in a nutshell allows us to query and save fields. So for example, we could do name equals dot name. Okay. I think, yeah, interesting. Cool. Let me just get the examples so we don't waste too much time on this. I mean, you know how it goes. Whenever you're live, things go unexpectedly, and what? Anyways, this is supposed to be working. So JQ allows us to filter JSON inputs, and okay, yeah, it's probably something with the, I see. Oh no, I see what the problem is. So the problem seems to be that the JQ that I pasted in, the JSON that I pasted in is of a weird shape. Oh, there we go. So yeah, basically what we can do is write name and dot name, and that way we can get the name field. But JQ also allows us to manipulate the data we get. And not to waste time, I will now just paste in the, yeah, I guess I will waste time. Okay, let's do it the old-fashioned way and just cut in some of this. What? Cool. So this thing is not cooperating today. We'll skip this. Basically, JQ allows you to filter the data and apply additional transformations to that. And the filter that I pasted in and is supposed to be working is the second piece of the information we need to provide to the FDC protocol so that we can get the data we want. And then the last component is the ABI signature of the Solidity struct that we want to store the data as. And how you can get that is a bit of a mystery. And I know I'm just putting things out there right now without really telling you what is going on and why we need them. But please just bear with me. Just the last thing that we need and that I have prepared is the way you can get a Solidity encoding for a struct is you can define it, and that's too small probably. So you can define a struct and then just make a simple function that takes that struct as input and make sure it's public. And what this will do is that when we compile this Solidity code in Hardhat, we will get the artifact for the whole contract, and we can extract the ABI signature from within the artifact. So if I go here to contracts FDC example and Web2 JSON, and this one, if I just search for ABI signature hack or just ABI signature, you can, sorry, is it this one? Yeah. If I search for ABI signature hack, I can extract the only component from here, and this will be the ABI signature of the Solidity struct that we want to save the data as. What I just did is I've given you a recipe of how you can use Flare's data connector without actually telling you what the Flare data connector is or what the workflow for it is. So let me now do that. I will once again go to the Flare Developer Hub. Nope, not this one. The Flare Developer Hub, because there is a handy diagram right here under user workflow. And let's open the image in the new tab. Ideally, I would now go there and point things out as I spell them, but they told me that I am supposed to talk into the microphone, so unfortunately no acrobatics here. But basically, this is the workflow for the Flare data connector. We start with some external data that we are interested in, and then we need to prepare an attestation request for the FDC protocol. To do that, we can use a verifier server provided by Flare. And all this does is it allows us to send data that we need as a JSON to the verifier server, and it will convert it into encoded data. And we can then, when we get the encoded data back, pass the data to the FDC protocol, which will decode it and start the whole process. And then the machinery will run in the background. I won't go into detail into how that works right now, so you can ask more about it afterwards or at the booth. But suffice it to say, we get back data and proof that that data is valid. Or rather, we can go to one of the Flare validators, which we call data providers, and request data from them. And then we can encode the data ourselves and generate the Merkle proof and compare the proof that we have generated with the one that is written on chain. And it has been written on chain by the consensus of all the validators. So basically, once we get data back from the validator, we can calculate the proof and see that the data is indeed valid ourselves. And yeah, once we have the data, we can pass it on to our smart contracts, which will then utilize it. So one last thing from me is I will run the script. So within the scripts, FDC example Web2 JSON TS, in the Flare Hardhat Starter, the script here basically goes through the whole workflow that I have described for us. And this is what I meant when I said that the code in this repository can serve as a baseline building block for you, because this is a working example script. All you need to do is take it, modify it, change it so it suits whatever your project is, which is, I think, is kind of neat. So yeah, I'll talk you through the steps as they happen. So first of all, this is the data that we send to the verifier server. So you can see this is the URL, that the API that we are accessing. We are accessing character number 3, and you're free to guess who this Star Wars character is. It will be a get method without headers or query params or body, but you can also provide those. And this is the post-process JQ that didn't work on the JQ playground, and the ABI signature that I've shown you. And we can see that the response we get from the verifier server is that our request is OK. And the data is valid, and ABI encoded request is the thing that we want. And we take this ABI encoded request and submit it to the FDC hub contract on one of the Flare chains. We also need to calculate the round ID of the request so we can actually request the data, the proof for the correct thing. And what is happening now is we are waiting for the round to finalize, which takes some time, but no more than 180 seconds, because we need to get the consensus and everything. Yeah, we can also check the round progress at the link here. So I would say that the third request is probably ours. We got 99% acceptance rate, in the sense that 99% of the validators told us that they are able to provide the data that we want and generate the proof. One said that they cannot, but it doesn't matter. If we go under advanced and finalizations, we can see if our round has finalized yet, and it would be the number 49. So we can see that the round has finalized. And this is the proof that we got back, or rather, this is the proof response. This is the data we requested, but encoded. And these are all the proofs that have been provided to us. And then we can decode the data, which I won't go into detail about. But basically, we can decode the data and then send it to a smart contract. And the data that we got back is R2D2, who stars in 6 movies. It has the ID 3 as we requested, and a BMI of 34. Whatever that means in this case. Yeah, we just took its R2D2's weight and divided it by its height in meters squared, and got 34, which is obese, if I'm correct. But yeah, that would be all from me. We have 2 minutes to spare, so more time for questions. Thank you for joining me. Yeah, I see 2 hands.
Oh, great presentation. I was just curious, how could you like integrate this in like maybe like a website, you know, like flow? Like for example, if I want to build like a website with like MetaMask smart contracts, how would we like integrate like Flare into that?
I don't know on the specifics, but I know it can be done. Mm-hmm. So yeah, I mean, this is a simple TypeScript script. So yeah,
Do you have like maybe like templates that show that off?
Unfortunately, no. I mean, all the templates that we have are these scripts, which are single script files. Mm-hmm. The specifics of how it can be implemented as a server, I think I'll leave that up to you.
Oh, okay. So we could just like do it in the back end, right?
Yeah.
Okay, cool. Yeah, that makes sense.
There was another hand there.
Thanks for the presentation. It was really nice.
Yeah.
For data which is not, let's say, open.
Yeah.
For data which is in a paid API, which has like credentials.
Yeah. Yeah, that also works. You just need to provide I mean, with locked APIs, you need API keys, which you need to provide to them. There is an example of how you can do it with.
Try to do that like with Chainlink, like they had some kind of somewhat similar. It was a bit like the event was a bit tough for the credential thing. For some reason they couldn't sync up Oracle or whatever.
I mean, if you look at weather insurance example here, for example, Mintemp insurance and resolve policy, you can see that there should be a I think there in this example we are taking data from Open Weather API, which gives you it is free to use, but it gives you API keys to rate limit you. And if you look at this example on your own, you will see how. Oh yeah, this one. I was just trying to see where we pass it in. Yeah, we pass it in as query params. So if you can get an API key, you can also access locked APIs. Yeah.
Is there any way from when you put this data on chain?
Yeah.
Is there any way, like, let's say, if I put it like it was from Star Wars or Star Wars, fake Star Wars? Like,
Yeah.
Is there any way, like, you also like see the proof, but it's like from has been taken from Star Wars, or not fake Star Wars?
Yeah. I mean, you operate in the Web2 JSON.proof Solidity structs. Oh yeah, sorry, I forgot to repeat the questions. So yeah, the question was how we can verify the proof, basically.
Yeah, but to make sure that like other people can check it and like the proof you put is from Star Wars, official Star Wars, not like some fake Star Wars.
Yeah. So the way they can check that is that the proof Solidity struct includes the URL and all the query params so that they can check it themselves.
Thank you.
Any further questions?
Maybe I have one. So you show us how to store data on chain, but if we need some manipulation with data, querying data and so on and so forth, so we need to do it on our side. So we need to download this data and all this stuff on the backend.
So the question is, how can we manipulate the data we get from the website? And basically, you can do it through the JQ filter. JQ is I guess, a programming language which allows you to perform simple manipulations on data. And you can basically write your own filter and pass it in as one of the attestation request parameters. And the validators will do that for you and just give you the Solidity struct that you want.
So it means so they give me a result.
Yeah.
Of my I don't know, something kind of query.
Yeah. They give you the result.
Filtering, grouping, and something.
That's right.
Thanks.
Any other questions?
So usually, how long will it take to like from requesting a proof and the data to like it's confirmed on the chain?
So the question is how long will it take usually from the start of the process to the end? I think that usually it takes. Sometimes this happens very quick, but it will never take more than 180 seconds. I think that I would say that like 40 seconds is the average, but I don't have data about that.
So it's like we can continuously request data and maybe every 1 minute, and the contract will have the latest data all the time.
Yeah, data can be requested continuously. Further requests will just be sent to the next round and the consecutive rounds. But yeah, data can be requested non-stop. Yeah. Any other questions? I think this is time. So thank you all for joining me for this workshop. If you have additional questions or problems with using the examples, visit us at booth. We'll be happy to help you. And yeah, thank you for coming here.